systems of equations, solving by elimination. So today we're going to algebraically determine or find the point where two lines intersect. And I know that it says third method, and today we'll be using this as our second method, just because I'm teaching it in a different order from last year. So this method is called linear combinations or elimination. In order to do so, we must do the following, and here are the steps you can always refer back to. Look at both equations and try to find the opposite coefficients. Opposite meaning a plus and a minus, and coefficients are the number that's attached to the variable. Okay, so that 4 is the coefficient, so 4x, coefficient is 4. So once we've done that, if there's no opposite coefficients, you must create some by multiplying one or both of the equations so that you get opposite coefficients and the same coefficient. Once you have a pair of opposite coefficients, you can add the two equations together. Add the two equations together, and one of the variables will cancel out. Solve for the remaining variable and then plug it back into either one of the equations to solve for the other variable. So for this first one, I have some steps all laid out for us. We'll be going through each of the steps one at a time. So our two equations are 4x plus 3y equals 16, 2x minus 3y equals 8. Are there any opposite coefficients that we could cancel or eliminate out? Okay, so we're looking for opposite signs with the same number attached to a variable. And yes, right here. Yes, we have a 3y and a negative 3y. 3y is positive, so positive 3y and a negative 3y. Let's add the two equations together since we have those opposite coefficients. So we have 4x plus 3y equals 16 and a 2x minus 3y equals 8. And notice that I have everything sort of lined up nicely so that I can add straight up and down. So 4x plus 2x equals 6x. 3y minus 3y equals a 0, so plus 0. And then that all equals 16 plus 8 is 24. So we've added those together. Solve for the remaining variable. Notice that we have a 6x plus 0 equals 24. The only variable we have left is this x. We're going to solve for x. The 0 goes away, so we have 6x equals 24. I can divide both sides by 6, and so x equals 4. We've solved for our variable. Step 4, plug the variable back into any equation to solve for the other variable. So I'm going to take this, x equals 4, and I'm going to plug it back into this equation or into this equation. It is your choice. You can choose either one of those to plug it back into. I'll do the second one just because it has smaller numbers. So let's see. So 2x minus 3y equals 8. If I'm plugging in 4 for x, I'll have 2 times 4 minus 3y equals 8. So 8 minus 3y equals 8. Subtract 8 from both sides. Negative 3y equals 0. If I divide by negative 3, y will equal 0. So now the solution to this systems of equations is a coordinate. It's x comma y. X equaled 4, y equals 0. So 4 comma 0. Now I'll show you what it looks like when we graph. Not that you have to do this, but just to show you that it works out either way. Now on the test, if it does ask you to solve using elimination or substitution, I do need it to be solved algebraically. So 4x plus 3y equals 16. So there's my first line. And 2x minus 3y equals 8. Okay, hopefully my intersection point or my solution is 4, 0, and it is, so perfect. All right, let's do one more of these together, and then I'll leave you to solve the rest on your own. So let's do the first one together. So I have a negative 2x minus y equals negative 7, and a 3x plus y equals 9. So looking for opposite signs, I have opposite signs there, but when I look at the coefficient, I have a 2 and a 3. So that definitely won't work. Moving on to the y variable. I have a minus and I have a plus, but I notice that there's actually not any coefficients. Remember, you can always add a 1 in front of the variable if there's no variable given. So now I have a negative 1 and a positive 1. So I am able to add these two equations together. So negative 2x plus 3x is a 1x. Negative 1y plus 1y equals 0. So plus 0 equals negative 7 plus 9 is a 2. So 1x equals 2. X equals 2. So I'm going to highlight that 2 so I don't forget about it. I want to make sure that it's easy to find when I need it. And I'll take that x variable and I'll plug it back into one of the equations above. I'll choose the second one just because it was positive numbers and I didn't want to deal with negative numbers. But either one would work. 3 times 2 plus y equals 9. So we plugged that 2 in right for x. And we'll solve for y. So 6 plus y equals 9. If we subtract 6 from both sides, y would equal 3. And I'll highlight that so it sticks out nicely for us. And our solution is always an x comma a y. So we have 2 comma 3. Now if you like to double check all of your work and be extra careful, you could always graph these two equations right into Desmos and see if that intersection point matches up with the solution that you found algebraically. If it does, you're correct. If not, you have some algebraic mistake that you should go back and fix. So go ahead and try the other 3 problems and let me know how they go.